Alrighty, so this week we're going to go look at some groundwater stuff in this module. So we talked about rivers, you know about how water moves in the surface and different parts of streams and rivers. Now we want to look at the water that sinks into the ground. And so groundwater is sinking into the ground for a couple different reasons, but mostly it's because the ground has some porosity, which means there's some open space there. And so that might be easier to understand if you have like sands or gravel, even some dirt. We know that when water hits the ground, there's a portion that gets absorbed because there's basically space between those pieces of sediment. It'll sink down to some level until there isn't any more space. Sometimes that's a different rock type, like a granite potentially that doesn't have any porosity. And then the water will just fill up the remaining spaces. And then we can get what's called a water table, which is kind of the difference between the open spaces that are full of water and the open spaces that are not full of water. That boundary there we call the water table. And we can drill into the subsurface and extract that water if conditions are right. Now also we can have porosity in rocks themselves, but not all rocks. We need rocks that have some porosity, some open space. And that's typically going to be sandstones, limestones, things like that. A lot of metamorphic and igneous rocks don't have high porosity, so we can't really store water in them. The exception, of course, is that highly fractured rock. Those fractures count as porosity, and water can move through those fractures. A lot of times they connect, and so fractured rocks can make good, what we call aquifers. These are layers that have a high porosity and a high what's called permeability. And that's just the ability for the fluid to actually move through the sediment or the rock or whatever it's moving through. So there's a PowerPoint here with a little video. You can certainly watch that. We're going to go through that in class, of course, and kind of review what's going on there. The additional stuff that we want you to do outside of class, of course, is there's an article that talks a little bit about the groundwater in Arizona. And so you can go ahead and take a look at that. There's the Earth Revealed, which is once again just kind of an overview of the groundwater material. So you can go ahead and watch that. And then once again, it should just be reinforcing the information that we talk about in class. And then finally, there's some questions I'm going to have you answer on the groundwater homework. So just some additional questions that either aren't posed in the lecture quiz or the other quizzes. And there's a little diagram that I want you to draw on a little bit. So you can, in Microsoft Word, you should have the ability to draw a couple lines, so you should be able to do that. If not, of course, you can print it and then just handwrite it, take a picture, upload it, whatever you need to do to get me a copy of that homework, and you can do. And of course, if you run into any issues, feel free to let me know, either in class or through email. Other than that, I know most of you will probably not see this until later in the week, but Scott from class did throw up a email that is letting people know that there is a show on Sunday, I believe at 3 p.m. that talks about the water crisis across the U.S. and potentially the world, not sure, but you can check your email, and he posted that to everybody. So if you get a chance, you can take a look at that. Try and watch it myself. Maybe we can chat about it in class a little bit, or maybe we'll see some little clips from that. Anyway, that's what we're doing this week, and I forget the lab. I think we're doing Arizona geology this week in lab, but we'll get to do that together. Okay, any other issues, feel free to contact me.